One of my students, Kavya, had a very interesting doubt in this question. Let us first read this question and then look at Kavya's doubt. A sphere of mass 6 kg is tied to two ropes. This is one rope, that is the other rope. Okay? It is hanging at rest as it is shown in this diagram. Then the horizontal rope is cut. So we're going to use scissors to cut this horizontal rope. Find the tension in the other rope. So we want to find the tension in that rope. And we have been told to take G as 10 meters per second square. So what is this doubt that Kavya had in this question? And how do we solve this question? Before I answer how do we solve this question, let us look at Kavya's doubt. Okay? So Kavya's doubt is that once you cut this horizontal rope, then effectively you just have this, right? And what are the forces acting on this? There are only two forces. There's going to be the weight mg vertically down, and there's going to be just one tension force T acting like that, right? Because you have cut this horizontal rope. Now we can resolve this tension vertically and horizontally. So we can resolve tension into the vertical and the horizontal components. How do I do that? Well, this angle is given as 60 degrees. So if you think of the vertical line here, the angle that this makes with the vertical will be 60 degrees, right? Vertical is parallel, and this is like a transversal, so alternate angles must be equal. So you can say that the vertical line here, this tension makes an angle 60 degrees with the vertical, which means T cos 60 will be the vertical component and T sin 60 will be the horizontal component. So Kavya resolved the tension forces like this. Then she said opposite vertical forces must cancel. So T cos 60 must be equal to mg, which means T must be equal to mg by cos 60. Now what is cos 60? Half. So T must be mg by half. Now the value of m is given, it is 6, g is 10, so 6 into 10 by half, 60 by half, which is 120 newtons. Looks good, right? Unfortunately, the book says that this answer is wrong. So Kavya's question is, why is this solution wrong? Before we proceed, please pause and think about this doubt. Before we get to Kavya's doubt, we must understand very carefully what do we mean when we say forces cancel. To understand this, I'm going to use this smooth floor. There is a 3 kg block on this floor. There is a force of 9 newtons acting towards the left on this block and a force F acting towards the right. Clearly, these two forces are acting in opposite directions, right? Does this mean that F and 9 newtons will cancel? Well, if this 3 kg block was always going to remain at rest, then you can say F and 9 newtons, they must cancel. But is that necessary? No, right? It doesn't always mean that they have to cancel. Why? Because I didn't tell you that this 3 kg block will permanently remain at rest. I can make this force 7 newtons, I can make this 12 newtons, it's my choice, right? So F doesn't have to be equal to 9 newtons and in the opposite direction. It doesn't have to cancel because this 3 kg block could be accelerating. Let us say it is accelerating in that direction with 2 meters per second square. Can you still say F is equal to 9 newtons? No, right? Clearly that is not correct. We have to always use Newton's second law. Net force is mass into acceleration. Net force is mass into acceleration. So suppose I use that in this situation, then I can say F minus 9, which is the net force towards the right, F minus 9 is mass into acceleration, 3 kg into 2 meters per second square. So 3 into 2, 6. So F must be 9 plus 6, 15 newtons. So clearly F in this case is not equal to 9 newtons. You can see that very easily, right? So two forces need not cancel even though they are in opposite directions. So when can we say that forces cancel? In a situation like this, you can say forces cancel when the acceleration is 0. When the acceleration is 0, then clearly ma will be 0, so the net force will be 0. So then you can say forces cancel. Okay? So never directly cancel forces. In Newton's law problems, never directly cancel forces. Just because they look like they are opposite does not mean that they are cancelling. Always write net force is mass into acceleration. Then think about the acceleration. If the acceleration turns out to be 0, then you can say net force is 0. Okay? Never directly cancel forces. So with this understanding, let us now look at Kavya's doubt. Let us now look at this question that Kavya was trying to solve. A sphere of mass 6 kg. So this is the sphere of mass 6 kg. It is tied to two ropes, one horizontal rope and one rope that is inclined like that. It is hanging at rest. Then the horizontal rope is cut. In the beginning, the sphere is hanging at rest. Then we bring this scissors here and we cut this rope. Once I cut this rope, there is nothing holding that sphere like that. So will it still remain at rest? No, right? It is going to move in a circular path like this. So that means it's going to go down this way. Now think about it. It starts from rest and it is moving in this direction. So that means it must have a tangential acceleration. Basically, it is moving along the tangent to this circle. So at this instant, when you cut the rope, this sphere is going to have a tangential acceleration. Now, the acceleration is tangential. Does that mean that the vertical acceleration is 0? No. You see that there is this acceleration clearly must have a vertical component. How do I find out that vertical component? It also has a horizontal component. How do I find that out? Let us think about it. Now, this angle is 60 degrees. So, if I draw a vertical line, this angle will be 60 degrees. Which means with the horizontal, it will make an angle of 30 degrees. And so this tangent will make an angle of 60 degrees with the horizontal. So if A makes an angle of 60 degrees with the horizontal, its component horizontally will be A cos 60 degrees. And the vertical component will be A sin 60 degrees. Don't worry about the exact calculation. All I'm interested in right now is for you to understand that there is a non-zero vertical acceleration. That is very important to answer Kavya's doubt, okay? Because the acceleration is A in this direction, it means that there is a non-zero component of the acceleration vertically. Let us now get to Kavya's doubt, okay? So Kavya says that once you have cut the horizontal rope, there are only two forces acting on the sphere. One is the weight mg and the other is the tension force T. And since the tension force angle with the vertical is 60 degrees, the component of the tension vertically must be T cos 60 degrees and its component horizontally must be T sin 60 degrees. Now the vertical components must cancel, and so she writes T cos 60 degrees is equal to mg, cos 60 is half, so T by 2 is mg, T must be 2 mg, 2 into 6 into 10, that gives us 120 newtons. But this is wrong. Why is this wrong? Because what is the meaning of this statement? T cos 60 is equal to mg. Why are you able to write this? Why are these two forces cancelling? They can only cancel if the acceleration in the vertical direction is 0. Is the acceleration 0? No. So this is wrong because the vertical acceleration is not 0. There is a tangential acceleration. The tangential acceleration A has a vertical component. So that means you cannot write this statement. So what statement then can you write? You have to write that the net force is mass into acceleration. You always have to write Newton's law. Okay? I'm going to solve this. I'm going to tell you what is the right way to solve it. Once you have resolved the tension forces like that, then we will see that there is a nice shorter way to solve this. Okay? This will help us understand why Kavya's approach is not correct. Let us focus on this. So if I wanted to write the vertical equation, right? Vertical Newton's second law statement. The net force in the vertical direction. What is the net force in the vertical direction? mg minus t cos 60 degrees. It is not 0. mg minus t cos 60 degrees is not 0. It is m into the acceleration in the vertical direction. Kavya has assumed it to be 0. That's why she gets t cos 60 degrees is equal to mg, which is not correct, right? So mg minus t cos 60 degrees is m into this acceleration, a sin 60 degrees. Okay, but then how do I go about solving? T is a variable I don't know. M, of course, I know. G, I know. A, I don't know. T, I don't know. I need one more equation. What is the second equation? You know that the acceleration horizontally is a cos 60 degrees and the force, the only force in the horizontal direction is t sin 60 degrees. So if I write Newton's second law for the horizontal direction, I will get t sin 60 degrees, right? That is the horizontal force is equal to mass into a cos 60 degrees. Mass into a cos 60 degrees. Net force in the horizontal direction is mass into acceleration in the horizontal direction. For each direction, you can write net force is mass into acceleration. Okay, so if I now look at this, I can figure out that m into a must be t sin 60 degrees by cos 60 degrees. Well, that is t tan 60 degrees. So you can write MA is t tan 60 degrees. Of course, tan 60 is root 3. We can substitute that. But I will leave it as tan 60 degrees. And then we can use this here. Because here you see you have MA. If I substitute t tan 60 degrees, then I will get MA sin 60 will be t tan 60 sin 60. Let us rewrite this equation. So I write mg minus t cos 60 degrees, which is the same as what I have there, is instead of MA, I am going to substitute t tan 60 degrees. So t tan 60 degrees sin 60 degrees. So which means mg must be equal to t cos 60 degrees plus, because I can take it to that side, t cos 60 degrees plus t tan 60 degrees sin 60 degrees. Okay. Now, of course, I can substitute the value for cos 60 degrees, which is half. Tan 60 degrees is root 3. Sin 60 degrees is root 3 by 2. So, root 3 into root 3 by 2 will give me 3 by 2. So, I'm going to get half t plus 3 by 2t, which of course is 2t. So, that means mg is equal to 2t, which means t is mg by 2. Here we got t is 2 mg, whereas here we are getting t is mg by 2. Now, what is m? 6 kg, right? So, 6 into 10 by 2, which is 30 newtons. So, this is the correct answer. The tension is 30 newtons, not 120 newtons. This is wrong because there is a vertical component of the acceleration. So, you cannot say that this force and this force cancels. You have to say net force is mass into acceleration. Okay. Now, this is a very long way to solve it, right? Is there a shorter way? Yes, a much shorter way to solve this. The reason I did this is because Kavya had already resolved the tension into the vertical and the horizontal component. You don't start by resolving forces. You start by looking at acceleration. Let us now look at the shorter way to solve this question. Let us now look at a very short solution for this question. We know that when we cut the horizontal rope, this sphere starts from rest and moves along this circular arc. It starts from rest and moves in this direction, so it accelerates tangentially. Now, if I look at the vertical direction, this acceleration will have a component, right? Horizontal direction, it will have a component. In what direction it will not have a component? In the radial direction. Perpendicular to the tangent is the radial direction. So, in this direction, the acceleration component will be 0. So, the radial acceleration will be 0. Please remember, starting from rest is important because if it already had a velocity, then there will be a centripetal acceleration v square by r. Right now, the velocity is 0. So, therefore, we don't need to worry about that. This component of the acceleration is 0. Okay, so the radial acceleration is 0. Why is that important? Because we know that this acceleration is 0. If we resolve forces in this direction, then we can say that the net force must be mass into 0, and therefore we can find out that the net force must be 0. Let us do that. So let us mark all the forces on the sphere. One is of course the gravitational force mg, which is vertical, and the tension force, which is T, which is along the radial direction. Now T is already in the radial direction. I don't need to resolve it. Okay, I need to resolve mg in the radial direction. Now this radial direction makes a angle of 60 degrees with the vertical. This is vertical, so this angle will be 60 degrees, and so if I resolve mg, I'll get mg cos 60 in this direction, and the perpendicular direction will be mg sin 60. Now I want to look at the net force in the radial direction. What is the net force in the radial direction? T minus mg cos 60. That must be mass into acceleration, which is 0. So writing Newton's second law for this direction, T minus mg cos 60 is m into 0. m into 0. Of course, m into 0 is 0. So that means T is equal to mg cos 60 degrees. M is 6, g is 10, cos 60 is half. So 6 into 10 into half, that gives me 30 newtons. So you can see that the tension is 30 newtons. It comes out in just one step here. Okay? Because we use the fact that acceleration is tangential, so the radial acceleration is 0. Therefore, T minus mg cos 60 degrees must be 0. And therefore, T must be 30 newtons. So I hope you have understood this solution. If you like this video, please hit the subscribe button below. And if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.